Hello students, this is question number 6 of week 5 tutorial. So the question is, let the random variables x and y be uniformly distributed in the triangular region D, where D is bounded by x equals to 0, x equals to 2y, x equals to 2. And we have to find the value for fy given x equals to 1 of y. Okay. So we have to find fy given x equals to 1 of y. So how can we write? Here we can write fxy of 1 comma y joint PDF divided by fx of 1 marginal PDF for x. Okay, we have to find these two values. So we know the region D is uniformly distributed between the limits. So we'll try to write all the limits here. So we'll draw the region first. So the region is bounded by these limits, right? So here I'm drawing two axes, x and y. Okay, so x equals to 0 is here, 1 is here, and 2 is here. Similarly, I can write y equals to 1 and 2 here. So we'll write x equals to we'll draw x equals to 2y line first. So the slope is 1 by 2. Okay. So when the value of x is 0, y is also 0. Okay. And then when the value of x is 1, then y's value is half, right? So I'll draw 2 points here to see this line's equation. So when x equals to 2, then y is equals to 1. This is the line. This line equation is x equals to 2y. Okay. Now this line is x equals to 2. So this will go from here like this. Okay. So I'll write only up to this portion where these two lines will cut. And x equals to 0 is what? This is y axis. Okay. Now these are the limits. This is the triangular region. We have x and y uniformly distributed. Okay. Now we'll find joint PDF for x and y. So from here, first of all, we know that the area of this region is the joint PDF, right? So area of D is 1 by 2. Since it is a triangular, it's 1 by 2 into this length, 2 into this length, 1 base into height. So this is 1. This is the joint PDF for x and y. Okay. So this will be 1. So when x is going from x equals to 2y to this line is x equals to 2. So for x equals to 2y to x equals to 2, and from y equals to 0. So 0 should be less than y, less than 1, right? So these are the limits for x and y. Then we have the joint PDF of 1 here, otherwise 0. Okay, this is the joint PDF now. What we have to do is, again what we have to find is joint marginal density of x to find this value. So how can we find the marginal density of x here? So marginal density of x of 1 is, we have to integrate over y here. So I'll write for marginal density of x. So this will be from 0 to x by 2. Okay, why we are taking the integrals from 0 to x by 2? So I'll write in different color here. Okay, so y is going from, see this blue color line. So here this x, it is going from this. So this x axis, here y is equals to 0, and here this equation of line is x equals to 2y. So y is equals to what? X by 2, right? So that's why we are integrating over 0 to x by 2. These are the limits of y. Okay, and we are integrating over this limit for this to find the marginal PDF here. Now fxy of xy is here. So it is 1. So from 0 to x by 2, 1 dy. We know it is y from 0 to x by 2. This is nothing but x by 2. Okay, so this is the marginal PDF for x. Now we have to find marginal PDF of x at value equals to 1. So fx of 1 is just substituting the value of x here, it will be equals to 1 by 2. So what we have found out until now, we have found out the marginal PDF and we have found out the joint PDF also. So just substituting these two values here to find fy given x equals to 1 of y is fx of y, 1y is 1 divided by fx of 1 is 1 by 2. So this is 2. This is the answer.